So to discuss complex numbers, we will have to discuss both real numbers and imaginary numbers. Real numbers can be found on a number line, such as this one, and include all integers, such as -10, -5, +5, +8, fractions, such as -2/3 or 33/7, and irrational numbers, such as the square root of 2. But what we won't find on a number line are imaginary numbers. Imaginary numbers are not considered real numbers since they cannot be found on the number line. So for example, two numbers that can be found on the number line are negative square root of 9 or -3 and the square root of 9 or +3. 9i, which is equal to the square root of -9. That is not equivalent to negative square root of 9. This negative's on the inside, this one's on the outside. Same thing over here. Our radicand 9 is positive. This one it's negative. So in neither case would our imaginary number be found anywhere on this number line. So it is a different kind of number. The imaginary unit I is equal to the square root of -1 and can be used to remove the negative from a radicand, such as the -9 we just saw. So the square root of -9 is equal to the square root of 9 times the square root of -1. Since any two radicals can be multiplied, that means we can break up this radical, or the radicand specifically, into two of its factors. So when we have a negative radicand, we can break this up into two factors, the -1, so we take the negative out, and then whatever the integer was. So by doing that, the square root of -9 is equal to the square root of 9. So now we can find the square root for this radical, which would be 3. And we have the imaginary unit, the square root of -1, which is I. So we can find the square root of a negative radicand, except in this case it will lead to an imaginary number instead of a real number. Same thing if we had the square root of -16. The square root of -16 is equal to the square root of 16 times the square root of -1. By doing so, we can simplify this radical. The square root of 16 is equal to 4, and the square root of -1 is our imaginary unit I, so we would get 4i. So now that we know what imaginary numbers are, we can discuss complex numbers, which combine a real number and an imaginary number. The standard form of a complex number has a real number a and an imaginary number bi. So for example, 4 plus 8i is a complex number. We have our real number 4 and our imaginary number 8i. The real number and or the imaginary number can be negative as well. So -6 is our real number here, and -10i is our imaginary number here. Now complex numbers in an equation actually act the same as regular expressions. So if two complex numbers are equal, then the real numbers are equal to each other and the imaginary numbers are equal to each other. So it's almost like we combine two equations into one. So 5 minus 6i is equal to x plus yi. So in this equation, the real number 5 is equal to the real number on the right side, x. So 5 is equal to x would be one of the equations here, our real equation. And now our imaginary equation would be -6 is equal to y. The I is found on both sides, so we can drop it as far as if we're trying to solve for y, for example. But in any case, our second equation involves our imaginary numbers. Our first one involves our real numbers. The equality rule just lets us know that whatever's on the left side equals whatever's on the right side when we have an equal sign, just like a normal equation. Except you must remember that on the left side, the real number is only equal to the real number on the right side, and the imaginary number or expression on the left side is only equal to the imaginary number or expression on the right side. So you'll deal with them separately when solving for variables. So for example, let's say you were asked to solve for x and y and then check the answers, and you were given the equation x minus 2 plus y plus 4i is equal to 8 minus 10i. So on the left side of our equation, we have an expression that represents our real number. This will be equal to our expression for the real number on the right side. Same thing with the imaginary numbers. The expression on the left side that represents our imaginary number equals the term on the right side that represents our imaginary number. So the first thing that we will want to do is step 1, set the real numbers equal to each other. So we have x minus 2 is equal to 8. And now by removing the imaginary numbers from this, we can solve for x. So we'll want to add 2 to both sides to isolate x on the left side. And 8 plus 2 shows us that x would be equal to 10. And now we'll find y separately. So step 3, set the imaginary numbers equal to each other. So on the left side, the expression that represents our imaginary number is y plus 4. And on the right side, it would be negative 10. We can leave the i's out. So we have y plus 4 is equal to negative 10. And now we'll want to solve for y. So we'll subtract 4 from both sides, leaving us with y is equal to negative 10 minus 4, which would be negative 14. So we got y is equal to negative 14 and x is equal to 10. So now the last step would be to check the answers by plugging them into the original equation. X minus 2 plus y plus 4i is equal to 8 minus 10i. So we plug in x is equal to 10 here, and we plug in y is equal to negative 14 here, and that gives us 10 minus 2, which would be 8. So the real number on the left side is equal to the real number on the right side, so that checks out. So x is equal to 10. And when we plug in negative 14 for y, we get negative 14 plus 4. That would give us negative 10i. And the imaginary number on the left side, negative 10i, winds up being equal to the imaginary number on the right side, negative 10i. So that confirms that y is equal to negative 14. So again, the equality rule is just a rule that helps us understand that complex numbers wind up working similarly to normal equations. You set the real numbers equal to each other and solve for the variable. You set the imaginary numbers equal to each other and solve for the variable. And then you can check the answers by plugging them back into the original equation. Let's have you try a few practice questions. Solve for x and y. Check the answers. Question number 1. X plus 6 plus y minus 5i is equal to 13 minus 7i. Question number 2. X minus 4 plus 2y plus 1i is equal to 20 plus y minus 6i. And question number 3. 2x plus 2 plus 10 minus yi is equal to x plus 4 plus 2y plus 4i. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, set the real numbers equal to each other. So on the left side we have x plus 6 as the expression that represents our real number. And on the right side, we have 13 as our real number. So we have x plus 6 is equal to 13. And now we solve for x by subtracting 6 from both sides, giving us x is equal to 13 minus 6, which would be 7. So we solve for x, and now we can solve for y by setting the imaginary numbers equal to each other. So that gives us y minus 5 is equal to negative 7. We can leave the i's out. And now we can solve for y by adding 5 to both sides. Negative 7 plus 5 gives us negative 2. So we wind up with y is equal to negative 2. So now we know x is equal to 7 and y is equal to negative 2. So step 5, we could check the answers by plugging them into the original equation. X plus 6 plus y minus 5i is equal to 13 minus 7i. So for x, we plug in 7, giving us 7 plus 6, which would be equal to 13. And that's the same number on the right side, so that checks out. For y, we have negative 2, giving us negative 2 minus 5, which is negative 7i, as our imaginary number on the left side. And that's equal to negative 7i, the imaginary number on the right side. So that confirms that the answer to question number 1 is x is equal to 7 and y is equal to negative 2. Question number 2. Step 1, set the real numbers equal to each other. So that gives us x minus 4 is equal to 20. We then want to solve for x, so we'll add 4 to both sides. 20 plus 4 is equal to 24. So we get x is equal to 24. And now we solve for y by setting the imaginary numbers equal to each other. So that would be 2y plus 1 is equal to y minus 6. And now we want to solve for y. So we'll start by subtracting y from both sides. So we get rid of the y on this side, and now our y is just on one side. 2y minus y gives us y, plus 1 is equal to negative 6. And now we'll subtract 1 from both sides to isolate this y on the left side. Negative 6 minus 1 is negative 7. So we get y is equal to negative 7. And now that we know the values for both x and y, we can check the answers by plugging them into the original equation. X minus 4 plus 2y plus 1i is equal to 20 plus y minus 6i. So we plug in x is equal to 24 here, and we get 24 minus 4, which is equal to 20. And the real number on the left side, 20, equals the real number on the right side, 20. So that confirms that x is equal to 24. And for y is equal to negative 7, we plug that in here and here, giving you 2 times negative 7, which is negative 14. Negative 14 plus 1 is equal to negative 13. And on the right side, we have y minus 6, which would be negative 7 minus 6, which is equal to negative 13i. So the imaginary numbers are the same on both sides, negative 13i and negative 13i, thus confirming that y does equal negative 7. Question number 3. Step 1, set the real numbers equal to each other. So we have 2x minus 2 is equal to x plus 4. And now we want to solve for x, so we'll start by subtracting x from both sides. So we negate x on one side and just bring the x's to one side. 2x minus x is equal to x minus 2 is equal to 4. And now that we've done that, we have x minus 2 is equal to 4. So the next thing we'll want to do is add 2 to both sides to get rid of this number, negative 2. When we do so, 4 plus 2 is equal to 6. So we get x is equal to 6. Step 4, set the imaginary numbers equal to each other. So that would be 10 minus y is equal to 2y plus 4. And now we want to solve for y. So we'll start by adding y to both sides. That will get rid of y on the left side. Negative y plus y would be 0. So we'll have our y's on just one side. So that gives us 10 is equal to 2y plus y is 3y plus 4. And now that we only have one y in our equation, we can isolate our y the way we normally would. So we first want to get rid of this 4 by subtracting 4 from both sides. 10 minus 4 is equal to 6, and that's equal to 3y. To get rid of the coefficient 3, we'll divide both sides by 3. 6 divided by 3 is equal to 2. So we get y is equal to 2. And now check the answers by plugging them into the original equation. 2x minus 2 plus 10 minus yi is equal to x plus 4 plus 2y plus 4i. You could check x by plugging it in here and here, giving you 2 times 6, which is 12. 12 minus 2 gives you 10. So the real number on the left side is 10. And on the right side, we have 6 plus 4, which would be equal to 10. So the real number on the right side equals the real number on the left side, which means x does in fact equal 6. And for y, we plug in 2 here and here, giving us 10 minus 2, which would be 8i on the left side. On the right side, 2 times 2 would give us 4. 4 plus 4 would give us 8i on the right side of the equation also, thus confirming that y does in fact equal positive 2.